For this question, under DC conditions, you have to find out I, IL, and VC, and the energy stored in the capacitor and the inductor. So under DC conditions, under DC conditions, a capacitor would become an open circuit, and an inductor would become a short circuit. So you can rewrite this circuit as the passive components remain the same. There's a short circuit where the inductor is, and there's an open circuit where the capacitor is. The rest of it stays the same. This 12 volt, 1 ohm, 5 ohm, and 4 ohm. So there's a current I flowing here, and IL is flowing through where the inductor was. Since this is an open circuit, there's no current flowing through the 4 ohm resistor. So you can simplify this circuit by removing that loop. So you have two resistors and a voltage source. That's 12 volt, that's 1 ohm, and that's 5 ohm. So that's I and IL. In this circuit, you can easily calculate the current. I would be equal to IL since it's in the same loop. So we can use I is V by R, voltage by resistance. So I would be 12 divided by the total resistance is 6, since they both are in series. 1 and 5 are in series. So it's 1 plus 5. So you would get it as 2 amps. You found out I and IL. You have to find out the voltage across the capacitor. So if you see in the circuit, the capacitor is in parallel with the 5 ohm resistor. So the voltage across the capacitor and the 5 ohm resistor would be the same. If you calculate the voltage across the 5 ohm resistor, that's the same as VC. So VC would be current flowing through the 5 ohm resistor is 2 multiplied by the resistance is 5. So you would get it as 10 volt. You calculated the first part of the question, I and VC. Next you have to calculate the energy stored in the capacitor and the inductor. So for energy, for the capacitor, the energy stored would be 1 by 2 C voltage across the capacitor squared, and for the inductor, the energy is 1 by 2 inductance times the current flowing through the inductor square. You know the capacitance and you know the voltage, you know the inductance and you know the current flowing through the inductor. So you just substitute all the values. For the capacitor, it's 1 by 2, the capacitance is 1, and the voltage across it is 10 squared. That would give you 100 by 2, that's 50 joules. And for the inductor, the inductance is 2 Henry multiplied by the current is 2 ampere. So you would get 4 joule.